So today we're working on graphing different sine functions or equations of sine. And the reason that they say sine is your parent function is because a cosine graph is actually just a transformed version of the sine function. So cosine is a phase shifted sine. This isn't very big, is it? Let me try and zoom this in a little bit more. So when we're using this, we are still going to use our, let's just, there we go. There we go. We are going to use like our sine or our cosine relationships, but when we get to a couple questions a little bit later on where we're supposed to come up with an equation for the graph, you're going to see how they can be named either sine or cosine. It just depends on what the student sees. Okay, so it's a pairs activity, but because we're in summer and not in class and COVID and all that fun stuff, I'm just going to graph all of these. What you were supposed to do is you were supposed to choose two of the equations, and then your partner would choose two of the equations, and then you would graph, and then you would compare the graphs and teach the other one. So we're just going to do all of them together. We're doing all four of them. So first things first, here's an equation. And it's sine. So if it's sine, I'm thinking middle, high, middle, low, middle. That's the pattern. What do I need to know? It's got an amp of 2, which means it's going to go up 2 or down 2 from the amp line. The amp line, or the vertical shift, is at 0. So that is true. What else do I need to know? Okay, let's figure out the period. The period is 360 degrees, whoopsies, divided by k, and our k value happens right here. It's outside the bracket. Now, it does say up here in the bubble, it's like, oh, careful, watch out for the hidden brackets. When we get into these questions with 3 and 4, we have to get that 1/2 and the 1/3 into the k value, which is outside of the bracket. So we have to factor in these two, but we're not there yet. So with this question, we're going to plug in 2, whoopsie-daisies. We're going to put it in blue. And we're going to say 360 divided by 2 is 180. So it takes 180 degrees, seconds, minutes, days, hours, meters, whatever we're doing to finish one full cycle. And then the last thing it has is a phase shift. Okay, so phase shift, 45, and if it's negative, we do the opposite, right? Okay, so they want us to at least one cycle for each graph. So we'll put that there. Because there's no vertical translation up or down, I'm going to make my graph right in the middle. If there was a vertical translation up or down, like when we get into these ones, you'll see that I'll draw my x-axis a little bit differently depending on the type of translation. Okay, so here's this axis, here's this axis. Let's start breaking it up. I have to do 4 sections that give us a total of 180, okay? So if I have 180 divided by 2, that's 90, divided by 2 is 45, perfect. The fact that 45 is a factor of 180 means that when I'm setting up my graph, because I've got a phase shift, it's pretty nice. Okay, I'm going to let every 2 represent one step. 2, 2. So here's our 180 right there. And then there'd be 1 there. So there's our 4. I didn't have to draw that one. I just put it to show you that we're going every 2. So half of 180 is 90. Half of 90 is 45. 45 plus 90 gives us this one, 135. Okay, so the first thing I do is figure out my scale, which is the most difficult thing to do. Not going to lie. Then I throw on my amp line, even though it's not a real thing, just so I know where my middle is when I'm doing my points. Then I like to, I don't draw this on, but I like to know how high and how low I can go. So I'm allowed to go up to, you know what, just to make this a little bit weirder, I'm going to make that one 1. I'm going to make that one 2. So every 2 jumps is worth 1. So I like to show, just because it's me graphing, where there's like, these are my restriction lines, because the graph is going to go up to and down to from the amp line, which is green. So this is like my high and this is my low, because this is our um, amp line, and our, sorry, amplitude goes up and it goes down from that axis line or that amp line. So what else do I need to know? Right now I'm going to put on some, I'm going to put a midway point. This is my midway graph. Middle, high, middle, low, middle. This has like some of the transformations in there, but not all of them. Just to get an idea. Then what I'm going to do is I'm going to say, okay, what transformations are we missing? I took care of that. I took care of that. I took care of that. I didn't do this one. So I'm going to take all of my purple points and I'm going to shift them right 45. So this point, instead of being at 0, is now going to be at 45. So it's going to jump 2 blocks because 2 blocks is worth 45. 2 block jump. This one, 2 block jump. This one, 2 block jump. This one, 2 block jump. And then red ends up being our 1 cycle. Oh, I did it. Of the graph. So this is y equals 2 sine 2 x minus 45 degrees. I think that's what the equation was. 2 sine 2 x minus 45. Okay. How are we doing for time? I think this is going to be lots of videos today.